Okay, hello everyone. I've got the top of the hour on my clock, so we're going to get started. We've got quite a bit to go through today. So thank you for joining me. I hope you're doing well and enjoying the spring weather. Today, the focus of our presentation is going to be on using the GeoWeb 3D soil confinement system for both traditional paved and unpaved road improvement systems. So we're going to cover both of those aspects today. Ooh, excuse me, there we go. So I'm your host, Sam Justice, and I'm a licensed professional engineer in the state of Wisconsin. I have degrees in civil and geotechnical engineering. I am one of the engineers here at Presto Geosystems, and we manufacture erosion control, stormwater management, and porous pavement products. And all of our products are made in the upper Midwest in the United States. We're near the Green Bay area, if you're familiar. And through an extensive national and international distribution network, we offer technical and site support, as well as a free project evaluation with our in-house design engineering team, which I'm part of, so little plug for us. So some of the things that I hope you get out of today's presentation: understand the benefits of using a soil stabilization system for both paved and unpaved roads, including using local low-quality fill and reducing your total cross-section depth, and building roads over soft subgrades. Then we're also going to cover how the system can reduce vertical pressures and subbase movement, and then how to utilize unpaved gravel surfaces for positive environmental impacts. So during the presentation, everybody's muted. So if you do have questions, type them in the questions tab in the GoToWebinar file there that you have, and I'll get to those once I'm done with the presentation so we can all talk about it some more. So first, a little bit of background on Presto Geosystems. We worked with the U.S. Army Corps of Engineers to develop the GeoCell technology in the late 1970s, and then we've been innovating in this market ever since. Our products have been used in over 200 countries and in every state in the U.S. And we go beyond simply providing a product. We're going to help you provide a complete stabilizing solution for your project. So we do operate in three main product areas. The first is going to be soil stabilization using our GeoWeb GeoCells, which can be used for load support, slope and channel protection, and then also constructing green retaining walls. Then we also cover porous pavements. We have both a vegetated and a stone surface solution. And then we also offer lightweight and reusable construction mats. So that's a lot of stuff to cover, and today we're going to focus on using the GeoWeb GeoCells, and as I said, in particular, how they can apply to road projects for load support solutions. So let's start with a little bit about how the GeoWeb stabilization system works, what it means, and how it can provide benefits for both paved and unpaved surfaces. So the GeoWeb system consists of two main attributes. The first is going to be the cell or the container size. The cells come in three diameters: small, medium, and large, and then heights of 3, 4, 6, 8, and 12 inches. So 5 options for depth. So the cell aperture, the opening, and the height are going to be selected following an evaluation of project-specific needs and site conditions. So there's no one right solution that we can apply to everybody. It is going to be dependent on what your needs are and what your conditions are. And so another thing I want to point out is going to be the ultrasonically welded seam. And this is where all of the connecting points are. This is a very important aspect about how the GeoCells function. The stronger the seam strength, the better the performance of the GeoCell overall. A strong seam allows for the use of heavier infill materials, the ability to be placed on steeper and taller slopes, and better overall lifetime performance. The GeoWeb system is produced using high-quality virgin high-density polyethylene, HDPE. And so it produces consistently strong welds at all of the cell junctions, while also maintaining semi-rigid ductile properties within the cell walls and a high stress crack resistance, including an overall toughness and long-term durability in your environment. So our geocells are made with that HDPE, and they don't use any fillers or exotic polymer alloy blends, which can ultimately end up reducing that weld strength. And it reduces your environmental stress crack resistance as well. So there are some competing geocells on the market that do have that sort of exotic polymer alloy in the name of increasing cell wall stiffness. But to avoid weld failures and the damaging effects of differential settlement, uniformity in performance across all of the elements of a geocell system is more important than just focusing on cell wall stiffness alone. So there's a lot of basically polymer science that goes into this, and if you do have questions, we're happy to talk about it. But basically, we're saying look at a geocell in all aspects, not just in a single function like the cell stiffness, to when you're looking at what type of geocell to use. So there were two main attributes. So the second attribute of the GeoWeb system is actually going to be the infill material that you choose. So it's going to be what you put into the cells, into those containers. And so an important benefit of the GeoWeb system is that even a low quality aggregate, a sand, or even certain salvaged materials can be used to infill the cells. Using salvaged aggregate or sand, even things like recycled concrete or recycled asphalt, can save significant amount of time and money on hauling costs. And we can also eliminate the fines within the material. So if you want to have a clean washed stone, then the cells can provide confinement and aid in compaction of those cohesionless soils. It provides an apparent cohesion to the system. And without those fines, you can significantly improve the drainage and let the water flow from the surface down through the system freely, preventing poor pressure buildup and global failure of the cross section. And the ability to use sands and other low quality aggregates really sets the GeoWeb system apart from things like planar geogrids or geotextiles. And that's a function of the fact that it has a defined depth. It's a 3D system. And so things like geogrids usually require a high quality material that has a really high friction angle of those materials, like a really good engineered stone, to achieve their optimal performance. With the GeoWeb system, low friction angle materials are just fine. And the GeoWeb panels can achieve their full potential even when you're using salvaged material or low quality material. So just an aspect of the system that provides some really huge cost savings, something to consider. So in order for a geocell system to perform uniformly, it is critical that both the factory welded junctions, so those internal seams that I mentioned earlier, and field joined junctions that connect the individual panels. So these are a mechanical connector connecting individual panels to create a single whole system. And you want both of these junctions, both internal and mechanical, to perform at a level that's going to be commensurate with the cell walls. So you want the junctions and the cell walls to be equally strong. You don't want one to massively outperform the other. So the three primary elements of any geocell system, including the GeoWeb system, include the cell walls, the internal junctions, and the mechanical junctions, which are going to be your connectors. And they all must perform uniformly as a complete system. Therefore, an incremental improvement in one characteristic, such as that cell wall stiffness, is only going to be valuable if a complementary improvement is made in the other components of the system. So if the junctions and the connectors are also made stiffer. That's why you want something like the Virgin HDPE, because it's going to be uniform across all of the different components. You're not just focusing on a single aspect. And so we've been using HDPE for the GeoWeb system for over 40 years, and we've really perfected our formulation, and it's really stood the test of time. So for most typical sites, the GeoWeb system is going to retain its durability for greater than 50 years, which is usually more than sufficient for an average project. And we've done lab testing indicating over 150 years without degradation, even at full exposure to the elements. So you know that this is going to be a long-term solution. And we stand behind our numbers and our lab testing so that you can deliver certainty in the solution as you build with materials that you can trust. So we're going to help you make sure you're comfortable using this system, even if it's your first time. Okay, so there are some other system components that are all the supporting pieces that help the GeoWeb system really protect your road surface and your subbase layers, and also ensure relative uniform performance of the interconnected system. And it keeps saying that, uniform performance. That's what you really want to focus on. So with that, you're protecting against things like non-uniform deformation and differential settlement when you have applied loads, in this case, vehicle loads. So we have kind of a typical cross-section that we're going to go through for a load support application. So you start with your subbase. It's going to have varying strength. We typically see it expressed as the California bearing ratio, the CBR percentage, but there are some other measurements as well. Usually any sort of geotechnical testing that you do is going to provide you with some measure of your subgrade strength. So then you decide whether or not you need a planar geosynthetic material. Typically, it's going to be a woven or a non-woven geotextile, and a lot of that is going to be based on your system application. Then perhaps a subbase layer of an aggregate material is going to be needed. Typically, if your subgrade soil is very poor, you're going to need this base layer. Then you'll lay down the GeoWeb material, put in the desired infill material. So again, that's going to be that stone, it could be sand, salvaged material, whatever you choose. And then typically you're going to put a little bit of a wear surface over this. So basically you're going to overfill the GeoWeb panels so that you don't see the plastic material. That's going to be a wear surface or maybe a leveling course. And then also if you are going to put a paved surface on top of this, so if you're going to put an asphalt layer down, this is going to help provide a nice level, smooth surface for that paved surface. And so then it's just really important to realize that all of these components do work together, and you're not going to need every single one of them for every project. You might not need the base layer, you might not need the geosynthetic layer. If you're not paving the surface, obviously you don't need that. So just something to keep in mind, once you apply your load, this is how the whole system works together. So one last little bit of some technical knowledge here is going to be about how the GeoWeb 3D system works when a vertical load is applied. And so this is going to have the active earth pressures in the loaded cell, which in this case is going to be that center cell. So when the active earth pressures in that loaded cell push back against the passive pressures in all of the adjacent cells to form a stable system. And when being confined, the soil or the material within that loaded cell responds passively. The infill is limited in its movements. Those are those yellow arrows. The cells adjacent to that loaded cell provide the passive resistance, so the red or the orange arrows going back in. And then also the load is dispersed over a greater area into the lower layers. So each cell helps support the one around it. And in this way, the system significantly increases the apparent bearing capacity of the soil. The GeoWeb cell walls also transfer hoop stress. That's going to be those blue arrows in the diagram. And this is going to be important for keeping the system intact and creating what we call the mattress effect. So the strength of the seams around each cell and the material properties of the individual strips that make up the GeoWeb panels, and then also that mechanical connector that we've talked about that will connect all of the individual panels into a whole system. So all of these things work together and are important factors in determining how the GeoWeb GeoCell system can improve your load bearing capacity. Strong seams, semi-ductile resin properties, and those integrated connectors are all going to be critical to the uniformity, I'm going to keep mentioning it, uniformity in performance of the installed system over the entire lifetime of the project. The GeoWeb system and all of its accessories are specifically designed to work together to be an effective, permanent solution for roads in soft soil locations. And so in load support scenarios, which is what we're covering today, vertical deformation can only occur with either the compression or the compaction of the soil or through lateral movement of the soil. So basically getting pushed to the side and creating ruts. By spreading out the load in a classic granular fill approach, you can reduce the compaction of the near surface soils, but only with the GeoWeb cellular confinement can one ensure that no lateral shifting occurs, so you're not going to get those ruts. And the mattress effect reduces the stress reaching your subgrade. So all of these things work together. We've done a lot of testing, a lot of all of that to show how this all works, and we'd be happy to discuss that with you if you do have questions. But that's about as much as we're going to get into today. I do just kind of want to show this as a sort of diagram of how you can see the stresses on the subgrade, how they're affected with the GeoWeb system. So you have an unsupported subgrade on the left and then GeoWeb reinforcement on the right. And you can see how there's a complete elimination of the highest stresses on the surface with the GeoWeb reinforcement. There's no red or orange layer. And so these stresses are reduced and distributed over a wider area. That's that mattress effect. And so it's going to reduce the amount of stress reaching your subgrade and leads to a significant decrease in deflection and rutting. And by eliminating that lateral particle movement, because they're all confined within those GeoWeb cells, the system can stabilize the surface and eliminate the need for constant maintenance. So you're not having to go back, fill those in, regrade the surface. Okay, and so here you can actually see how the load support system works and how it can benefit when you're using an 80,000-pound loaded dump truck, which is going to be a standard AASHTO HS25 loading parameter. So anything that's going to be basically allowed on a highway without special permits. And so it's actually on a partially filled GeoWeb system. You can see there are empty cells there. So you can see how those cells push up against each other to help support the load, and that the adjacent cells need to be filled for support, but the whole system doesn't. So it's a great benefit to using the GeoWeb system that you don't have to have every cell completely filled before the road is usable. So you can reduce construction time and materials with this approach, basically use the GeoWeb system as its own access road. And you can also have about sometimes as much as a 50% reduction in the cross section compared to an unreinforced section. So you're really saving on materials, you're saving on construction time, all of that stuff. This is a great way to really speed that up. And so the purpose of all of this, of the GeoWeb system, is really quite simple. It's to stabilize the movement of unstable soils, both horizontally and vertically. So the weaker the subgrade conditions, the more practical the insertion of the GeoWeb system is into your design. So it's an engineered system integrating multiple types of geosynthetics with the best method of confinement and subgrade stress reduction in the industry. And so I do just kind of want to point out, today's discussion is going to focus on the GeoWeb system for load support applications. Other infrastructure applications can be things like intermodal yards, rail ballast reinforcement, steepened slopes, bridge approaches, vegetated swales, concrete lined channels, vertical MSE walls. Possibilities are endless. We're not going to get to those today. If you do have questions about those sorts of things, I'm more than happy to answer them for you, but it's just not going to be covered in this presentation. And finally, everybody always asks, does this actually work? You know, you put all this information out there, but what am I actually seeing? And so you can see a real difference in the same container yard. On the right side is the before picture without the GeoWeb system, and then the left with the GeoWeb system. And so this was with a fully loaded transport truck. So again, that HS25 loading. And you're going to see with every pass on the right side, those ruts are just going to keep getting deeper and deeper. You're going to have to go back, regrade the system. It's going to be a mess. On the left-hand side, you're not going to have to do that. You're not going to have to keep going back. Those ruts aren't going to get any deeper. They're not going to form, all of that good stuff. So yes, this does actually really work, and it is a great solution for a lot of different applications. Okay, so with all of that background, we can sort of kind of get started now. And so we're going to describe how the GeoWeb system works when it's placed at the surface to create a stabilized unpaved road or pavement section. So an aggregate surface has advantages in terms of things like saving on pavement costs. And when using the GeoWeb system, you can actually design a system that allows for stormwater infiltration and provides stormwater storage. So you have those positive environmental impacts as well. So things like site access roads, both temporary and permanent, are probably one of the most common applications for the GeoWeb system. This project was created to access oil resources over undeveloped, soft, spongy soils. And so you can see how this heavy loaded vehicle can drive on the GeoWeb system immediately after infilling to finish infilling as it goes forward. So like I said, you're using it as its own access road. So again, good time saver in terms of construction. And in this case, they were able to use readily available on-site sand infill so that they didn't need to buy and truck in expensive aggregate. So they were able to save on material costs, hauling costs, even CO2 reduction because there was less driving needed to bring all the materials in. So all sorts of good things to consider. And like I said, depending on how this your project needs, you can reduce your material requirements by as much as 50%. So huge savings there. So this was another site access project. It was for Duke Energy down in Florida, and they needed to install some new transmission towers through a wetland area. There were some really high winds from a Hurricane Michael. It actually demolished over 100 towers, all which had to be restored into this extremely soft subgrade. And you can see how deep those footprints are, all those boot prints. So if you can imagine how easily a person is sinking in this environment, no way you're going to get, heavy vehicles through there without just massive rutting. And so they actually decided to use the GeoWeb system for access and long-term maintenance roads, as well as the pads around the base of all of the transmission towers. So that saturated sand really can't support any type of vehicle load. So in this case, they chose to use an enhanced woven geotextile over the subgrade. And woven geotextiles can add additional strength to the system, and they're not going to get clogged by that sandy material. So they're still going to allow water movement, which is really important when you're in things like wetland environments, that you don't interrupt how that water flow happens, so you're not disrupting the environment. And then the GeoWeb panels were actually filled in with a low quality aggregate that was easily sourced and was able to be transported to the remote locations for this project. So you can see that's what's happening here in this photo. And once the panels are completely filled in here, you can see both wheeled and tracked equipment can drive over this system quite easily. Even when that infill material is sort of that low quality, in this case, there's some sand mixed in, you know that you have that. So normally it would be horrible to try and drive tracked equipment over sand. There's just no support for those tracks. But with the GeoWeb system, because everything's confined, you don't have to worry about that. You can keep going. You can have this be the access road for any type of maintenance equipment that you might need. So this is another typical problem that we see. So this is going to be at things like material handling yards when you have really heavy loads such as containers and reach stackers, which are going to have a much stronger ground pressure than a typical vehicle would. And so these tend to really tear up aggregate surfaces. It requires a lot of routine maintenance to make sure that you can drive through them, that they can still support the containers, all that stuff. So this project consisted of a 100-ton reach stacker and it had a really soft subgrade. It has CBR percentage of 2%, which is really, really soft. And so the reach stacker could only make a few passes before it would start causing ruts and it would get bogged down and they would need to come in and try and repair the yard. And obviously that's just not practical. So we worked with the engineer to come up with a value engineered solution. So this was something that we worked directly with them to try and help save on costs and material and all that. And we came up with a solution consisting of an 8-inch deep GeoWeb panel and then a woven geotextile underneath the panels to help support those loads. So the GeoWeb system was going to confine the infill. It controls shearing along the lateral and vertical movements, so there's no more rutting. You don't have to come back and constantly fix the surface after that reach stacker goes through. And so here you can see what that final solution ended up looking like. Basically you have the GeoWeb layer confining the fill, giving it strength, reducing that potential for rutting. And then you can also see that there's this wear surface over the top, so you're not actually seeing the GeoWeb panels. I mentioned this a little bit before. So you overfill the GeoWeb panels so that you don't see that plastic material, you just see a good, clean gravel yard. And then as you're driving over this wear surface, you're compacting the material into the GeoWeb panels to make sure it really doesn't move. So this is kind of what it's going to look like. If you do end up seeing the plastic material, if you have that overfill material get pushed away, or if you don't overfill enough to the point where you still see the plastic, that's fine. It's totally acceptable. You can continue using it. But this is generally sort of what people are hoping to see. It's a little nicer looking to not have that plastic visible. So, okay, so that's one project. Another one was a storage yard project in Mexico for Kansas City Southern Rail. So this was another value engineered solution. The original design called for 16 inches of reinforced concrete, but the cost was way over their budget. And the railroad reached out to us directly to come up with this value engineered solution. So we worked closely with the engineer to come up with our GeoWeb solution to eliminate the concrete surface entirely. So we moved to an aggregate surface solution to support an 80-ton reach stacker loading and container yard. So the design ended up consisting of a 6-inch deep GeoWeb panel and a 4-inch wear surface. So a total of 10 inches of just aggregate as opposed to that 16-inch reinforced concrete. And so this is something that we offered everybody. We want to work with you to get the best design for your site. We're not here to just sell you a product and then disappear. No, we're going to try and help get you the best materials, lower your cost, lower your cross-section depth, really try and help you with what you need for your project, not just sell you stuff. But so you can see the GeoWeb panels, in this case, were being filled in with a crushed limestone, and they were able to keep the fines relatively low. There was about 10% fines in the stone, so that they were able to have some storage of stormwater and keep that ability to infiltrate water into your subbase. And so this is just a great photo to show that infilling process. So your haul trucks can just dump the aggregate into large piles without damaging the GeoWeb panels. And then either with something like a small front end loader or similar equipment, the stone can be pushed into the empty cells while the equipment can then drive on the filled areas. Workers can also hand rake the stone into the cells to ensure that there's complete coverage and filling in. And so it's a fast and efficient process. Doesn't take any additional training. There's no expertise required. So you don't have to have specialty contractors come in and do this. Your crews that you're familiar with can come in and start doing this, day one. Nothing overly complicated about it. And so here you can see the final wear surface being finished to provide that solid surface to support the load. So after placement of that 4-inch wear surface, the railroad decided to add an asphalt tack coat as a surface stabilizer. So while the GeoWeb panels themselves help prevent movement of shifting of the aggregate, for extra peace of mind, you can add something like this tack coat or even a low strength cement grout over the surface, and then there's going to be absolutely no movement. That stuff's not going anywhere. But if you do that, you have to realize you're going to have less water infiltration. So, it's a bit of a give and take. Find out what's best for your site, but it's absolutely an option if you want, absolute zero movement of those particles. And so just for an easy sort of visual comparison of how much the GeoWeb system can reduce your pavement cross section, this graph shows an unreinforced depth in the blue line compared to the GeoWeb reinforced depth, the green line, over a lifetime of passes. So for a high traffic yard with 1 million lifetime passes, the GeoWeb system saved nearly 2 feet in overall cross section depth. So that's huge, and definitely something to consider if you know that you're going to be in one of these high traffic yards. So this does really work. We have the all of the research and everything to back it up. And sort of now we're going to shift gears for a minute, talk about some of the environmental aspects of using the GeoWeb system as a porous pavement. So stormwater regulations are becoming increasingly common, and a lot of project owners may choose to focus on meeting specific goals for site conditions if you're looking for things like LEED credits. And so we've seen how the GeoWeb system can help in poor site soil conditions, and it can also help when the focus is on sustainable solutions and managing stormwater on site. So by utilizing the GeoWeb with an aggregate surface system, you can make the best use of valuable high cost land and have the ability to meet green goals and initiatives. So reducing a site's overall environmental impact can help meet green infrastructure, low impact development, or green building goals when you're building in protected or densely populated areas. And it can also help you meet stormwater requirements that limit the amount of hard surface in your landscaping plans. So if you aren't allowed to put any more asphalt or concrete down, putting in an aggregate surface with the GeoWeb system is a great alternative. And so this is a really common sort of thing in large cities and in areas near protected waterways or wetlands. So for this specific project, local stormwater regulations limited that amount of hard surface pavement. So in order to expand the parking lot, business turned to the GeoWeb system with that aggregate infill for a permeable porous pavement. So the sections are filled in with that aggregate to create that porous pavement that allows for water to drain vertically into the natural groundwater system. The aggregate allows for infiltration when you keep the fines content low, so around 10% or less. You want to have a lot of void space between the stone to allow for that water movement. And with the GeoWeb panels, you can bridge soft, wet ground, creating access roads with little to no disturbance of the surrounding environment. So saturated soils usually can't support really any type of vehicle load, and adding just a simple geotextile is usually not going to be sufficient, especially since things like geotextiles can get clogged, especially if you're in a clay environment, they're going to get clogged and they're actually going to prevent that water movement. So using a clear stone in the GeoWeb allows for that water to flow both vertically and laterally through the system, limiting the impact in sensitive environmental locations in ways that a paved asphalt or concrete road would really disturb, and you need to make sure you get a lot of environmental permits. Putting in a porous pavement with the GeoWeb system can help reduce the amount of regulations that you run into. And the GeoWeb system can also support all types of highway traffic loading. Like I said, it's up to AASHTO H25 or even heavier. So it makes a great option for extending road shoulder areas. And so the GeoWeb system can be filled either with stone, or you can fill it with what we call engineered fill, which is a 2/3 aggregate, 1/3 topsoil mixture. That's what's in that inset photo. And so this allows for vegetation growth while still supporting those vehicle loads, so that you get a green shoulder, but that it could still support vehicles if they need to pull off. So both infill types can widen your roads for emergency access, and they can help manage stormwater runoff from your impervious asphalt pavement by catching that surface runoff and allowing the stormwater to infiltrate naturally and reduce erosion concerns along your pavement edges. So this heavy-duty permeable pavement project was actually at a steel fabricator's location in Pennsylvania. And so heavy single axle loads up to 150 tons were utilized at this site, and they had really soft subgrades with silts and clays. So really something that didn't have a lot of strength on its own. So there were lots of ruts. You can see these really deep potholes, lots of maintenance that they wanted to try and reduce. So a conventional concrete surface for these high load areas was considered, but it was really cost prohibitive. Plus, a permeable surface was desired for stormwater management. So the pavement was stabilized with the GeoWeb system and a highly permeable open graded aggregate. So the water infiltrates right at that point of impact, reducing surface runoff and reducing or potentially even eliminating the need for additional stormwater infrastructure, such as drainage swales or detention ponds. And this pavement has been operational for over 10 years, and it's still supporting these heavy vehicle loads while providing a stable surface for people to walk on. So like I said, these are long-term solutions. And so one important advantage to any unpaved yard utilizing GeoWeb stabilization is going to be that use of an open graded aggregate course. So since you don't need fines to achieve compaction when you're using the GeoWeb system, this system can actually act like an on-site detention basin, storing water within the void space of the GeoWeb infill. So a general rule of thumb is that 3/4 inch open graded aggregate has a void space of around 35 to 40%. So imagine how much water you could store within that void space to reduce stormwater runoff and ultimately have the ability to reduce stormwater pond volume and land requirements. So something that we're able to help with if you do have questions. And we've worked with a lot of regulators all over the US to know sort of what they're looking for and how our systems can help with that. Okay, so we're going to pivot now and talk about the GeoWeb system under hard pavements, and that includes things like asphalt, reinforced concrete, and then also roller compacted concrete. So lots of different pavement options. The GeoWeb system can be used in place of or in conjunction with a traditional aggregate layer beneath a paved asphalt or concrete road. It's still going to have that same mattress effect from the GeoWeb panels that we talked about in the beginning. It's still going to help bridge soft soils and add strength to weak subgrades. And when used as the base layer, the stiffening effects from that uniform system, bringing that word back, uniform, are going to be translated up through the surface layer, keeping your paved surface stable and in place, reducing your maintenance requirements. So you're not going to have, a lot of going back and fixing that asphalt or that concrete. Plus, the GeoWeb system allows for, again, that thinner cross section, again, as much as 50% thinner. So you're going to have less excavation required on site. And so that's great if you have things like shallow public utilities that you might need to avoid. So if you have limited excavation space, GeoWeb might be the way to go. So this is just sort of another picture showing that you don't need to have everything in place before you start working. So you can lay the GeoWeb system down, fill it in with your stone, and immediately start paving on it. And so you don't need to have any special cure time or wait time with the base before you start paving. You can just immediately get going. And it's your standard paving equipment, nothing special, nothing special about it. So you don't need any specialized equipment or contractors. You just use your standard equipment and get right to it. So like I said, all of the same benefits still apply for the GeoWeb system when it's used as a base layer, so when it's not at the surface. So you can still use that low quality aggregate or granular material, including salvaged material. And you can still have that stress reduction, so you can reduce the potential for deformation or settlement. So you're not going to get those alligator cracks, you're not going to get wheel ruts or drive lanes forming, and you're going to have a good strong base layer, which means a strong surface layer. And strong surface layers mean longer pavement lifetimes with less maintenance and section repair. So this is a pretty common project that we see. I'm sure we've all dealt with roads like the one in the upper left. Surface cracking, ruts, lots of patched areas that seem to start failing almost immediately. So this is what happens when a road is built over that weak base layer that can't fully support vehicle traffic. With the GeoWeb system, the failed asphalt and the base layers are removed, then the panels are laid down, filled in with a granular material, and then a fresh paved surface is placed over the panels. Now you've got that good strong base leading to a strong surface. It's going to look cleaner, it's going to last a lot longer. You're not going to need to go back and patch it, not going to have as much maintenance, all of those good positive things. So the GeoWeb system can be used under all types of roadways, from private drives to full service highways. So this was a project for the New Mexico State Highway and Transportation Department. Unable to proceed on a timely basis using any sort of conventional alternatives, such as super deep excavation with really thick base layers, or even using chemical stabilizers, the DOT turned to the GeoWeb system, and a local sand was able to be used as the infill material underneath an asphalt pavement. So nearly 200,000 square feet of GeoWeb panels went into the ground quickly, was pretty inexpensive compared to needing chemical stabilizers, and we were able to solve the DOT's budget and construction issues. So overall, a really great project. So this was a project for the Union Pacific Railroad. They had an auto storage yard out in San Francisco, California. So it was going to be offloading cars from large barges onto then train cars. So the original design included geogrids, high quality aggregate, and a really, really thick cross section. But when construction started, the subgrade was way too wet and it was too soft for the geogrids to be a cost-effective solution. So the engineer reached out to us. We were able to provide a value-engineered solution with the GeoWeb. So again, worked closely with the engineer and the railroad to provide our solution. And this had included a 6-inch base layer and a 6-inch deep GeoWeb panel, so a 12-inch total cross section. So that base layer provided additional support, but also was an area for water to be able to move underneath the asphalt surface to prevent poor pressure buildup. So because they knew that this was such a wet environment, they didn't want to have concerns about poor pressure building up underneath the asphalt and potential uplift because of it. So they added that base layer to have a thicker cross section to allow for free water movement without disturbing the surface layer. So again, a good mid-construction photo, expanding all the GeoWeb panels out and then filling in with stone. And really it becomes a really quick work. Once the contractors have done, just a little bit, they see that it's really fast, really easy. And really placing the panels is almost always faster than infilling them, even if you have equipment moving that stone. So you're not going to have to worry about like sequencing or anything like that. And then you can see they were able to place about a 4-inch asphalt paving layer over top of the GeoWeb panels. And again, just regular asphalt is used, and it was compacted with a standard smooth barrel roller. No special equipment, no special procedures are required, so you don't need extra training for your asphalt crews or anything like that. So this was another project. This was for a facility down in Florida where they had a roller compacted concrete solution that they wanted some value engineering on. So this was at an intermodal yard. that was going to have gantry trains, so really heavy loads. And part of the issue was that they were going to need to do up to 8 months of surcharge loading over the site to accelerate primary consolidation and protect against excessive settlement. And so, as expected, the long time frame to implement this preloading strategy was pretty unacceptable. And so, since this was a design build project, Presto Geosystems was asked to come and actually be part of the team to provide a new solution that would generate cost savings and still protect against those settlement concerns. So we were able to work with them for both of those pretty unique functions. And so the first feature was actually the ability to use inexpensive sand fill to replace expensive crushed limestone. So the original solution had a GeoGrid option, needed that expensive limestone. We were able to switch that to the GeoWeb system, able to use sand infill, saved a significant amount of money in construction time. And then the second big function was the ability to control short and long-term differential settlement to extend the lifetime of the pavement. So through that mattress effect that the GeoWeb system provides, we were able to function as a semi-rigid slab that improves load distribution and reduces the vertical stress that reaches that soft subgrade. So this not only reduces the overall magnitude of settlement, but it also protects against differential settlement. So it allows for primary consolidation of the subgrade materials to occur in a much more uniform and controlled manner in response to those applied vehicle loads. So the end result was a much more durable system with a longer lifetime pavement. And so by incorporating the GeoWeb system into this design, the project was completed on budget and ahead of schedule. Always things that people like to hear. So the design did consist of using an enhanced woven geotextile with the 6-inch deep GeoWeb panels, using that sand infill. And so using the combined strength of the woven geotextile and the GeoWeb panels provided that system the ability to control settlement and bridge the really soft soils. So this was a pretty unique site, had a really unique sort of solution that we were able to work with the engineer for, and this is something that we can always provide for you if you have questions. So you can see they're putting in the sand here, same as we've talked about. That staggered sort of construction really helps in reducing construction time, getting ahead of schedule. And then they were able to put roller compacted concrete on top of the GeoWeb system. And roller compacted concrete is kind of an interesting wear surface. It's basically a low slump, high PSI concrete that doesn't have any internal reinforcement. It's pretty popular in port areas and intermodal yards. Maybe you've run across it, maybe you haven't, but it is something that the GeoWeb system can help support. And so you can see right after they've placed it, you've got rollers on it, making sure it's a good smooth surface. And so they were able to actually reduce the pavement depth from 24 inches to 18 inches. And so they were able to reduce the amount of lifts that the concrete had to be placed into. So again, saving in time and construction. And so these are all things that we can help you with if you do have one of these sort of unique solutions that you're looking for. And just so you know, for all of our projects where the GeoWeb system is the base stabilization underneath asphalt or concrete, we follow the AASHTO method to determine, make sure that you're going to have an acceptable solution, so that we're not just making this up on the fly. We are following accepted standard practices for these sorts of things. And we do provide our calculations to you. So if you need those in the future, part of your bid package, make sure that everybody's comfortable using the solution. You have these with you as soon as we hand them off. Okay. So in summary, the GeoWeb load support system can be added to projects to provide a more stable and durable surface for unpaved areas, reducing maintenance and lifetime repairs. And then for paved surfaces, including asphalt, reinforced concrete and roller compacted concrete. The GeoWeb system reduces the pressure on the subgrade to reduce differential and long-term settlement, which is going to extend the lifetime of your pavement. The ability to use low-quality aggregates and sand can save a significant amount of money and hauling costs and material costs. And the ability to reduce the stress on your subgrade can potentially reduce the final thickness of your pavement. So we offer a complete system solution for roadways, parking lots, intermodal yards, and any other load-bearing applications. And we're going to help you with those based on your project-specific details and conditions. So we do offer technical assistance. So that's myself and the rest of the engineering team. We provide free design evaluations. So there's a form on our website. Fill it out with any information that you have. You can attach documents such as geotechnical reports or plan sets. Comes to us, and then we can provide this design evaluation. Gives you our recommendations for what products to use. Make sure that you get anchorage requirements if they're needed, geotextile requirements if they're needed. Basically, anything that's going to be required to give you the best design for your project needs. And we do deliver quality, and we have over 40 years of experience. We are the longest operating geocell manufacturer in the world, and we guarantee each shipment meets or exceeds our specifications. So you can deliver certainty and build with those materials that you trust. No disclaimers, no concerning fine print. Everything is what we say it is. So that's my presentation. Thank you all for attending. So I really hope you got something good out of this. If you do have any questions that you think of later, feel free to send them either to myself. My contact information is on the screen now, or we have a info@ email that you can find on our website, and you can submit any questions you have through there, and they get sent to myself and the engineering team, and we get back to you sort of right away to answer those questions that you may have. A little bit of housekeeping. We are making it faster and easier for you to obtain PDH certificates. You do earn 1 PDH credit for this presentation. So we have our webinar dashboard. So you can easily view our library of webinars and download PDH certificates for any on-demand webinars that you've completed. Your webinar dashboard is going to keep a record of what webinars you have completed along with your PDHs. So in 2 to 3 days, you will see an email from Presto Geosystems with more information about accessing your dashboard and other resources that might be useful. So please keep an eye out in 2 to 3 days. It's not coming today, but you should get it by the end of the week. But if you attended live today, you will receive a PDH certificate within 24 hours from GoToWebinar. It's not going to come from Presto Geosystems. It's going to come from GoToWebinar with a link to download your certificate. So make sure you check your spam folder, or if you have like email quarantines for your IT, look in there. Sometimes GoToWebinar gets caught. But so that's all our housekeeping. So I understand there's some questions that we get to. I do want to say, I have sort of reached the end of the hour. So if you do need to go, I really appreciate your time. The questions are going to be recorded with the webinar. So if you do need to go, keep an eye out for that webinar dashboard email, and then you can watch this webinar, skip to the end, and get the questions there. So if not, feel free to stay on, and let's see if we can't answer some of these questions. So some of them are going to be about how to reduce your, how you're reducing those vertical loads with the GeoWeb system, and how that affects, the cyclical loads or those running loads from vehicles. So it's not just, a building load that's sitting there, it's a live load. And so part of that is going to be, part of it is for the mattress effect that I talked about. So it's spreading out the load, so you're not having, basically point loads underneath your wheels. You're spreading them out over a larger area, so you're having a lower stress reach your subgrade. So if you have a soft subgrade, you're not putting as much pressure on it. And in terms of sort of the running loads, or the fact that these are moving vehicles, that's handled by the actual GeoWeb panels. And so that's there was that diagram back in the beginning where we talked about the loaded cell, and then the passive pressures from the adjacent cells, and then there's also the hoop stress from the cell walls. All of those things work together to support the system under that cyclical running load. So as you keep doing more and more passes, we know that the semi-rigid ductile properties of the GeoWeb system are able to support the load and then bounce back slightly once that load has been removed, so once you're not driving on it anymore. So it has the ability to handle that cyclic loading without long-term deformation or destruction to the GeoWeb panels. So they are going to last that lifetime of the project, so that the road stays strong and stable throughout however long you need it to. So there are some questions about the size of the panels. So that's a good question. So the GeoWeb panels are a very flexible system. So they open like an accordion, basically. So you can stretch them or lengthways or widthways, but they are going to have sort of a standard dimension. Like if you open it to get a nice diamond-shaped cell, it's going to have standard dimensions. We do have a number of section lengths to help try and fit your site needs based on how much area you need to cover. But you can also cut the panels if you need to. So the panels are standard 8.5 feet wide. You can stretch them a little wider and a little narrower. But if you were to say I have a 12-foot wide road that I need to cover, you could cut a panel in half so that you have one 8-foot panel and one 4-foot panel, so that you get a 12-foot wide road. And then you're still going to have the same mechanical junctions. So a connector piece to connect those two panels together. It's all going to still function, just the way it should. Cutting it is not going to have a detrimental effect to how the system is going to function. There's a question about that connector, so how the individual panels are connected. I mentioned them a couple times, but we do have what we call an ATRA key. So it's a small HDPE molded key that fits within the perforated cells of the GeoWeb. So the different panels will line up next to each other. Those cells will line up. You insert this key. It's a simple push and twist. So it's not, two pieces that you need to fit together or anything, but it's a simple key that you get, and the key is as strong or stronger than the GeoWeb cells themselves. And so that's one of those things that I talked about in the beginning, where you need to have all of these functions that need to be the same strength. Otherwise, you're going to have failure in one specific place. So by having the mechanical keys, these ATRA keys, be as strong as the GeoWeb panels, you know that they're going to be able to support the loads. So that's something that we have material research on if you're interested, but those come with the GeoWeb system, and it's a nice easy way to connect all of the panels. You don't need any equipment to do it. They don't need like electrical equipment, so it's not like you're stapling or anything. This is just a simple push and twist key. Some other questions. So again, about the GeoWeb panels being flexible. So they're not going to come on a roll like you might be familiar with for a geotextile. They are going to come on a pallet, but they're collapsed down and they're into a tight bundle that you then stretch out over your project site. So again, sort of like an accordion, you pull it out and you cover it over your site. But they do come and can be shipped directly to your site on a pallet, and then you just pull them out and cover your area. Any questions about what type of size of infill? So there's a lot of different options. You can go anywhere from say a coarse sand is going to be an acceptable infill up to an aggregate. If you do use aggregate, the size is going to be a little bit dependent on what you're looking for. If you want to have an aggregate surface that's going to have a little bit of water infiltration, you're going to want to use larger stone with less fine material so the water has a place to go. And the maximum size of your aggregate is going to be 1/3 the depth of the GeoWeb panel. So if you're using a 6-inch deep GeoWeb panel, it's probably our most common, the maximum size of your aggregate should be 2 inches. And so this just makes sure that you're not having a problem where you have one overly large stone within a cell and then no other stones in there, because that's not really filling it. You want to have, you know, a good strong fill in with each cell. And so by using the smaller stone, the 1/3 depth of the stone, that allows you to make sure that you've fully filled in the cell and it's going to have all of the function that it needs to. Something like an AASHTO 57 or a 67 stone are really common. If you are getting, you know, something from a material site, that's something that everyone really carries is a 57 or a 67 stone. But we typically recommend between 3/4 and 1.5 to 2 inches. But if you do have specific questions, or if you have a gradation of a salvaged material and you want to know if that's going to work, feel free to send us your gradations and we can let you know if it's going to be acceptable or not. So some questions about how the GeoWeb functions during flooding or excess water, things like that. So it's a great question. So if you know that you are in an area that's prone to flooding, or if you're, say, in a wetland, anything like that, you can take some precautions during installation, but really it's not going to have too much of an effect. So the GeoWeb panels themselves don't float, and especially once you've put, you know, a stone or, you know, your material in there, that you're not going to have sort of a floating system, so you don't have to worry about that. If you do have a flooding situation where you potentially would have uplift due to that excess of water, you could mitigate that potential by using stakes to hold it in. And so these are just simple, like, metal rebar stakes that you would connect to the GeoWeb panel and then hammer into the ground. And that would sort of prevent the panels from doing any uplift during a flooding event. So if you know that you're in that type of environment, you can do that beforehand. If it's something that you had no idea was going to happen and it did, and a wild flood happened, it's pretty easy to do any sort of repairs if necessary. It's unlikely that repairs would be needed. Because the system doesn't float, you have that, you know, gravity working against uplift. But if it does happen, or if movement happens, you can basically vacuum out the stone or your infill material, place the GeoWeb back where you needed it to be. I would then recommend you put those stakes in place to prevent that in the future. But then you just put the stone right back in and you're good to go. So there's really not too much effort needed in repair unless you had a lot of movement that you need to put back into its normal location. Somebody has a follow-up. So I mentioned, yes, the panels are a standard 8.5 feet wide. We have 5 section lengths. Those are anywhere between 17 and 32 feet. So those are our options. If you want to know specific, we have that information on our website, or feel free to email us and we can give you just that diagram saying, you know, here are the different section lengths, here's what the total area is going to cover for any given panel. PDH credits. So I did mention at the end, PDH credits are going to come either if you watched live, they're going to come directly from GoToWebinar. You'll get that email in about 24 hours. If you're watching on demand through the webinar dashboard, the dashboard will show that you completed the webinar, and you'll be able to download your certificate from the dashboard. So you can look for an email from Presto Geosystems by the end of the week for information about that dashboard, or look for an email from GoToWebinar within about a day if you watched live. But it looks like that is me going over our hour. So thank you for everybody that stayed with me. If you do have other questions, please feel free to reach out to me directly or through our website. I'm more than happy to answer any other questions that you may have. If you have any projects that you think the GeoWeb system might work for, we are more than happy to talk about that as well. Like I said, our evaluations are free. There's no cost to that. It usually takes 1 to 2 business days to get an answer back from us. So hopefully that's quick enough to get you any answers that you're looking for. So feel free to reach out to us at any time. We are always happy to hear from you. So thank you everybody for attending. I hope you all have a good day. Keep an eye out for those emails in the future, and I hope to see you at future webinars. Thanks.